What's up, everyone? Welcome back. Patrick here. Moving on to the next example, we have to take these two expressions here and we're going to have to rationalize the denominator for both of them. So starting with part A, we got the third root of 30 over 24. Now, first thing I would do here is I would actually simplify. I'm noticing that we could simplify the fraction, right? We could divide the numerator and denominator by 6, so that would be what? 5 over 4, like that. And then what I would do is I would distribute that third root to the numerator, so I'd have the third root of 5 over the third root of 4, like that. And so if we're going to rationalize the denominator, basically, that means that there can't be any roots in the denominator, right? We could only have integers in the denominator. So how would we get rid of that third root of 4? Well, notice that we're going to have to multiply the third root of 4 by itself twice, right? Because it's the third root, right? So for example, if you have like the square root of 3, you just have to multiply the square root of 3 by itself once to get 3. However, if I had the third root of 3, right, I got to multiply it 3 times like this in order to get rid of that third root, which would be 3 then, right? If this was the fourth root of 3, I would be multiplying it 4 times in order to get that 3, right? So that's what I'm doing here. I'm basically multiplying this third root of 4 3 times here in order to make it equal to 4 in the denominator. But I can't just multiply the denominator by these random values. What I do to the denominator in order to keep this equivalent, I have to also multiply the numerator by that, right? And so you'll have the third root of 5 times the third root of 4 times the third root of 4. And then, because these are all multiplying with the same root, right? If you have the nth root of a times the nth root of b, well, you could just combine those, and it could be the nth root of a times b. So you could multiply the 5, the 4, and the 4, which would give you 80. So you'd have the third root of 80 like that. So notice that at this point, we have just an integer in the denominator, but this can actually further simplify, right? So if we take this up here, the third root of 80, to simplify these kind of radicals, you got to think of, can we divide 80 by a number that could be third rooted? So what numbers can be third rooted? Well, we could third root 8, right? Third root of 8 is 2. We could also third root 27, which would be 3. We could third root 64, which would be 4. So we can make a list here of numbers that you could third root smoothly. And then we see, okay, can this 80 divide by any of these? Well, notice that the 80 can divide by the 8, obviously. So we can rewrite this third root of 80 as the third root of 8 times the third root of 10, right? 80 is equal to 8 times 10. And we keep that third root. We're just basically doing this rule, but we're going backwards now. We're splitting it up. And the reason why is because now the third root of 8, that's equal to 2, as we mentioned, times the third root of 10. And the third root of 10, we can't simplify that any further. The 10, we can't divide that by 8 smoothly, or 27, or 64, etc., right? You always want to see if that number can divide by one of these and get integers here. So notice the 80 we were able to break down, but the 10 we can't break down. So third root of 80, that's the same as 2 times the third root of 10. Well, if we bring that here, so that's going to be 2 times the third root of 10 over 4, and then notice the 2 over 4 simplifies to 1 over 2. And so 1 times the third root of 10 is just the third root of 10 over 2. And that right there is your final fully simplified answer. And then you could check these, right? So you can actually take this, plug it in your calculator, right? When you do the third root, just make sure this is in brackets. Another way you could do this is, if you're not going to third root it, you could do 30 over 24 to the power of 1 over 3. Just make sure you put that exponent in brackets when you're doing it in your calculator. So you could get the decimal for that, and then you could check the decimal for this, and the decimals should be the same. Moving on to part B, we have the fourth root of 2 over 3. So just like the last one, what I'm going to do is I am going to distribute that fourth root to the 2 and then the fourth root to the 3. And now if we're going to rationalize this denominator, right, we're going to have to multiply the fourth root of 3 by itself four times, sorry, fourth root of 3, right, because it's the fourth root. So fourth root of 3 multiplied by itself 4 times is going to end up giving us 3 in the denominator. However, what we do to the denominators, we also have to do to the numerators, right, to keep the original fraction equivalent, the original expression equivalent. These are all just like ones, right? This is like multiplying this original by 1 times 1 times 1, right? So it's keeping the original the same, it's just changing its format. And again, because we have the fourth root in all of these, we can multiply the numbers under the roots. So we have 2 times 3, which is 6, times 3, which is 18, times 3, which gives us 54. And so we'll have the fourth root of 54, like that. And then this can't simplify further, right? So if you think about numbers that could be fourth rooted, meaning numbers that would give us an integer after we fourth root it. So we would have like what, 16, right? The fourth root of 16 is 2. What's the next one? 81, right? The fourth root of 81 is 3. 256, right? The fourth root of 256 is 4. Or the next one would be 625, right? The fourth root of 625 would give us 5, right? So that would give us an integer. However, notice that none of these numbers here, you can't take the 54 and divide it by any of these, right? The 81, 256, 625 is obvious because 54 is less than those, but you can't take 54 and divide it by 16. That's not going to give us a smooth integer where we could like break this down to be the fourth root of 16 times the fourth root of some other integer, right? And simplify like we did with the other one. And so yeah, we're done. That's basically it. We rationalized the denominator. Again, you could check your answers. You could plug this in your calculator, plug this in your calculator, right? Another way you could plug this in is like 2 over 3 to the power of 1 over 4 or to the power of 0.25. And both of these decimals should be the same. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.